Imagine a world where everything we know about our planet is flipped on its head. Instead of a round, rotating globe, Earth is a flat disk floating through space. This idea might sound outlandish, but it's a concept that has been around for thousands of years, and even today, some people still question whether Earth is truly round. In this video, we're diving deep into what a flat Earth would actually mean. How would gravity work? Would there be an edge to fall off of? What would happen to our seasons, weather, and oceans? And, most importantly, would life as we know it even be possible? Brace yourself, because as we go through this journey, you'll see just how drastically our world and our understanding of the universe would change if the Earth were flat. Get ready to explore science, physics, and some pretty bizarre possibilities. This is What If Earth Was Flat? Let's start by painting a picture of what this flat Earth would look like. In flat Earth theories, the planet isn't a globe at all, but rather a giant disk, like a record or a pizza. And one big question that comes up is, what would keep everything on Earth from just falling off the edge? According to some flat Earth believers, a massive ice wall surrounds the planet's perimeter, acting as a natural boundary. This ice wall is even supposed to keep all the oceans contained and prevent anyone or anything from going beyond it. Now, this might sound like something out of fantasy, but it's a central concept in flat Earth thinking. Just imagine a circular Earth ringed by towering walls of ice. But if that's the case, then why hasn't anyone documented this wall? Why haven't we seen this bizarre boundary in photographs from space or from explorers venturing to the edges of Antarctica? And what would actually lie beyond it? Just endless space or something else entirely? One of the biggest questions a flat Earth raises is, what happens to gravity? On a spherical Earth, gravity works by pulling everything toward the center of the planet. This constant, central pull is what keeps us grounded and gives Earth its round shape. But on a flat Earth, gravity wouldn't work in the way we're used to. If gravity pulled toward the center of a disk, everything on the outer edges would actually be pulled inward, not down, causing a lot of chaos for anything or anyone trying to live there. So, some flat Earth theories suggest an alternative, that instead of gravity, the flat Earth itself is constantly accelerating upwards at a rate of 9.8 meters per second squared. This idea would simulate the effect of gravity, keeping us and everything else grounded by the feeling of an upward push from below. But here's where things get tricky. If we kept accelerating upwards indefinitely, eventually we'd reach the speed of light, a feat considered impossible according to Einstein's theories of relativity. Not to mention, if gravity didn't work the way it does on a round Earth, we'd see big problems in the way objects fall, plants grow, and even the way water behaves on Earth. Gravity isn't the only thing that would change on a flat Earth. Our weather, ocean currents, and even the way storms form would be completely different. On our round Earth, weather patterns are driven by the planet's rotation and something called the Coriolis effect. This effect, caused by the Earth spinning, is essential to creating stable weather systems, ocean currents, and even trade winds. But on a flat Earth, where there's no rotation and no Coriolis effect, weather would be chaotic and unpredictable. Imagine hurricanes that can't form because the rotational force that drives them just doesn't exist. Or imagine storms that don't follow any predictable paths, just moving at random across the landscape. Predicting the weather would be almost impossible, and extreme weather events could strike without warning. And then there's the question of oceans. On a flat Earth, with no gravity to hold water in place the way it does on a sphere, oceans might actually pool toward the center of the disk, leaving areas on the edges dry and desolate. Ocean currents as we know them might not even exist, leading to drastically different climates in different regions. So, in short, living on a flat Earth would mean coping with unpredictable, potentially extreme weather, and possibly dry, lifeless regions near the edges of the planet. So, what about day and night? Right now, our round Earth spins on its axis, giving us predictable cycles of day and night as different parts of the world rotate into and out of the sun's light. But if Earth were flat, it couldn't work this way. One theory is that the sun would move in a circular path above the disk, acting almost like a spotlight, shining light down in one area while leaving others in darkness. Imagine living on a part of the Earth where the sun just travels in a loop above, casting a constant, harsh light without the soft glow of a sunrise or the gradual fade of a sunset. In this model, day and night wouldn't flow smoothly. We'd experience harsh shifts as the sun moves across the sky, almost like flipping a light switch. And what about seasons? Those too would change. On a spherical Earth, the tilt of our axis as we orbit the sun gives us seasons. But on a flat Earth, seasons as we know them wouldn't exist. Instead, temperatures might vary erratically based on how close or far a region is from the sun's circular path. Some areas might get almost constant light, while others would barely see the sun at all. Space travel would be another huge challenge on a flat Earth. On our spherical planet, satellites orbit in a predictable path, and rockets launch up to break free of Earth's gravity. But if the Earth were flat, what would happen to satellites? Where would they orbit, and how would we send them to other planets? And if the sun and moon were simply moving above a flat Earth, then reaching outer space would become a very different challenge, one that could defy our current understanding of physics. And what about astronauts on the moon or the International Space Station? If the Earth were flat, their views of the planet would be vastly different from the images we've seen from space, showing the curvature and blue oceans of around Earth. Space exploration, as we know it, would look completely different, or perhaps not exist at all. Looking up at the night sky on a flat Earth would be a completely different experience. On a spherical Earth, constellations and stars shift based on your position and latitude. This is why people in the northern hemisphere see different stars than those in the southern hemisphere. But on a flat Earth, there would be no hemispheres, and everyone would see the same stars, no matter where they stood. And what about the motion of the planets, the phases of the moon, or even the cycles of distant galaxies? A flat Earth would fundamentally change our view of the universe and our understanding of celestial bodies. Without the spherical structure of Earth and the predictable positions of stars, our night sky would become unrecognizable, and our place in the universe would be completely unknown. It's fascinating to explore what a flat Earth might look like, but at the end of the day, science overwhelmingly shows that Earth is a sphere. From centuries of observation to the images taken from space, the evidence is everywhere. The curvature of the horizon, the way ships disappear when they sail far enough, the shadow Earth casts on the moon during a lunar eclipse, all of these clues point to one conclusion. Earth is round, and that shape gives us stable gravity, weather patterns, and a world that supports life as we know it. So, what if Earth were flat? The truth is, life as we know it simply wouldn't exist. The physics, weather, and even the way we move through space would change entirely, creating a world very different from our own. It's fun to imagine and wonder about these possibilities, but it's also a reminder of how incredible our round planet truly is. It's a planet designed by nature's own rules, and it's one that continues to fascinate and support us every day. So next time you look out at the horizon or gaze up at the stars, you can appreciate the science behind our spherical Earth and all the wonders it makes possible.